story to tell about what the Military Medical Research Enterprise has done to respond to emerging infectious diseases. But I grew up in HIV, so you guys are studying a little bit about that, but it's probably the hardest vaccine to make. And I think it's a good instructional case, and then we'll move on to learn a little bit about what we're doing for MERS, Ebola, and Zika at the rare. Okay, so this is about one thing that's going to include slides on therapeutics. But I just wanted to point out that the Military Medical Research Enterprise in the United States, and this has been contributed to, though, by partner militaries around the world, really has a distinguished place in the development of countermeasures for tropical diseases. And I think that any drug that you've ever taken from malaria was developed at the rare or stolen from the Nazis and then redeveloped at the rare. So it's a unique niche that military medical research has had in the United States, and it's a story I don't know that we tell well enough because it's a huge good news story, and the impact of the work that we've done has of course reached around the globe and not just improved the health and readiness of our troops. So these are some of the recent additions to the work that we've done, and to include the RD-134 trial, which didn't lead to a licensed HIV vaccine, but was a massive military effort that led to the first proof that this type of work is possible, that type of vaccine is possible. Okay, so types of vaccines. Quick review, there's lots of different types, right? You can have the live vaccine that's just attenuated. You can kill the vaccine. You can have a recombinant vaccine where you use another organ system to express portions of another organism or pathogen, or you can take one virus and put portions of another virus into it to allow it to express those parts, those antigens. Antigens are just what the infectious disease you want to protect against that you display to your immune system. Your immune system reacts against those antigens to make antibodies or cellular responses or both to protect you from those. And so you can actually use other viruses, for instance, a smallpox virus that's attenuated, and you can put in various parts of other, whether it's Ebola surface glycoprotein or an HIV envelope sequence, and you can use that in a vaccine product that will cause protection against those inserts. Yellow fever virus, someone tell me what kind of vaccine is that? Live attenuated. Hepatitis B? Yeah, that's recombinant. Okay, how about Pneumovax? Yeah, it's polysaccharide, that's the Pneumovax, and then there's the Prevnar's conjugate, that's the polysaccharide conjugated to a third. So a little bit about developing HIV vaccines. This is a very difficult vaccine to make for a number of reasons. Right? Most other diseases, people may have an infection, and if they survive, they develop natural immunity to whatever they did. This has never been documented with HIV. So that's not a model that we can look at. What is the immune response that allowed people to survive to clear it, and we just replicate that, elicit that with the HIV vaccine? We can't ask that question because that person doesn't exist, right? There's one person who has ever been cured following what it required a bone marrow transplant, but it was certainly not recovering by production of natural immunity. The other big challenge is that there are different subtypes all around the world, right? So the subtype that affects us in the United States and is really in most of the soldiers in the United States. And so this is one of the things that we learned, that despite one of the biggest reasons we thought we needed to protect against global HIV, because we sent people all over the world. If you actually look at the epidemiology of HIV in our soldiers, it really is mostly subtype. Just acquired here at home, perhaps in Europe. Not the exotic subtype, although there are some, for sure, to be acquired in Africa or Southeast Asia. And so we have a mission to develop a global vaccine, but it's important for us to know, and this is certainly informed the work we're doing at RARE, that it's subtype B that seems to be affecting our soldiers the most. The other challenge is that HIV hides and evades the immune system. And so it hides in tissues, and then it just mutates very rapidly. And so it's always beating the human immune system, and it's very easy to beat other immune responses that might be developed by response to it, or response to a vaccine. So we can learn a lot, though, by some people who have been infected for a very long time. Because there are some people who have been infected for many, many years, and they actually develop neutralizing antibodies that are incredibly broad and powerful. They are just one step behind their own virus, right? They may be many steps ahead of someone else's virus or able to protect against the infection of a virus, which is commonly not a whole swarm of viruses in chronically infected people, but just one single transmitted founder virus that comes through by mucosal exposure and infection. And so there's actually a whole field looking at the application, and we're involved in this, of these broadly neutralizing monoclonal antibodies that are derived from chronically infected people and using them in prevention, or maybe using them to treat people who are very newly infected and they have a less mature swarm of viruses. Okay, but some basics of vaccine development. Okay, so this is why, like I've been with the RARE for 7 years, and I'm just now kind of publishing my first manuscript on the vaccine that I've been working on for a long time, right? Because there are many, many steps, okay? There are preclinical animal models that are used. These are commonly non-human primates, but it starts with mice, right? And then those will be used to see, hey, these vaccine products, can they elicit antibody or cellular or both responses in these animals that would protect the animals and suggest that would work in humans. And then also, they will use things like preclinical tox studies in rabbits to say, just to inject and look at for surrounding tissue damage, otherwise evaluate will this be safe to give to humans, okay? So there's kind of like the will this work, and then the will this be safe questions you have to answer preclinically when you're developing a vaccine. And when the answers to both of those are yes, you can move into phase 1 clinical trials. And so these are typically people at low risk for getting whatever you're trying to protect against, whether it's HIV, you don't do these, you don't test a phase 1 Ebola vaccine in the middle of the Ebola outbreak, right? You do it in a phase who have zero risk of infection. You're just looking for preliminary safety and preliminary, what we call immunogenicity, or those immune responses that we're talking about. And a lot of times you'll do that, and you'll test a bunch of different doses in dose escalation, and then and what you'll try to do is pick a nice balance of what's producing the least, what we call reactogenicity or side effects, with the most immunogenicity or likelihood of protection by either antibodies or cellular responses or both. Okay, and so what you do in phase 1 will help you down select into phase 2, and there you're going to put that again, not to test whether it works, but to get broader information about the safety or efficacy. The safety and immunogenicity of the vaccine in a larger number of people in a more generalizable population, specifically in populations that you're talking about. So for HIV, Ebola, for example, a lot of the phase 1s would be done in the West and Europe. The phase 2s then started to go to non-endemic areas or people at low risk in Africa to look at those populations, because this is where most of the vaccine would be rolled out. So you look at those populations, you look at extended age ranges, you look, instead of picking just the healthiest, the very, very healthy, like the equivalent of the medical students, if medical students were still allowed to volunteer for research that you do in phase 1, you allow people to be a little less than perfectly healthy, right? Because you're going to try and roll out these vaccines in broader populations, so you can't just pick and choose in the middle of an academic, you have hypertension, so we can give this to you. It wasn't studied in you. So you have to study it in those people. And that's phase 2. And then we move on to phase 3 to start looking at efficacy. And this is once you've established that it's safe and immunogenic in a broad range of a target population that's relevant to the populations that you would roll the vaccine out in. Okay. And so, so whether it's HIV or any other vaccine, going through this whole progress of steps, takes many, many years, and is a huge logistical enterprise. So the vaccine trial phase 3 that's ongoing in Southern Africa right now for HIV is costing well in excess of $150 million. Okay, this is why these many candidates fail before they ever merit that type of investment. Okay, then there's licensure. Phase 4 is actually post-marketing surveillance. Okay. Okay, so how do we test when you're in these efficacy trials, right? How does that work? Well, and the example here is HIV, but you can apply it to many others. So you find healthy people who have some risk of getting HIV infection. So you'll do it in a place like Southern Africa, and you have done studies in the surrounding area to know that there's a predictable risk of incidence, and you use that to power your study. You say, I need to enroll this many people to show a difference between my placebo group and my vaccine group. Okay? So then you'll give some people the vaccine with other people the placebo randomly. Okay, and then you counsel everyone to avoid HIV infection, right? Now, of course, if no one gets HIV infected, your study fails, right? But it's your duty, nonetheless, to try and counsel people to avoid HIV infection. So it's an unusual place to be in, but there you have it. And you have to follow both groups when you have HIV infection rates, and if it's lower statistically in your vaccine group, then you're on to something, right? Okay. These same principles hold for other infections, but then how do you demonstrate efficacy after the outbreak is over and there's no risk of people acquiring it? Does anyone know about other ways that you can demonstrate efficacy outside of these human efficacy trials? Well, there's something called the animal rule, okay, which the FDA has, which essentially is if you establish what equals a protective response in non-human primates or the best possible model to replicate humans, and you determine what that correlate is, and then you test it in a bunch of vaccine in a bunch of humans, and you see if there is a protection or an immune response that equals what was protected in monkeys seen in humans. This is very difficult to do, and it's been many years since a vaccine has been licensed for the animal rule, but that's what you have to do for things like bioweapon threats. You're never going to be able to test those, right? We hope you're never be able to test those. And it's going to, and a lot of the major Ebola vaccine candidates now, this is their route to licensure, is this animal rule, because they can't test efficacy. Now, another way to get a good idea about early vaccine efficacy is what's called a controlled human infection model. These are challenge studies. It only works for some pathogens, but people might have heard of malaria challenge studies where people are given the vaccine or not and then exposed to the malaria. And then you see like controls, obviously they all get malaria. If you've done it right and the people have the vaccine, if not all of them do, then you may be onto something. This is a malaria challenge trial. This was pioneered at the RARE. It's a center of excellence for doing that work. And they're doing the biggest one in history, is enrolling right now. And at some point when they challenge people, they have to watch people very closely because they're going to be coming down from malaria, right? So you have to go into a hotel. They are renting out an entire hotel, the Malariat, for infection and treatment. And that is just one of the, and I'm an HIV researcher, but I signed up to be an investigator, right? I'm like, I would be there because this is history. And so I'm learning a lot about controlled human infection models. There are a bunch of now retired rare researchers who are developing a dengue human infection model up at SUNY in northern New York. And so they have to do it there, right? Because you don't want people developing dengue and then being bit by mosquitoes and then releasing, dengue into the mosquito population up there. So obviously this is not something you can do in Florida. We have a bunch of that vector, but this is like northern New York, and so it works. But the things you have to think about, there are some people thinking about doing a controlled human infection model for Zika. And so what could be the issue with Zika? I mean, when you think about it, it's really just a problem for a pregnant woman, right? So if you get enroll a bunch of men, give them a little bit of Zika, most people aren't symptomatic, they're not, you give them an attenuated strain. What do you?
Just they transmit it sexually to their partners.
Yeah, okay, but let's just say you have, they're not allowed to do that. No, that's you. Right? Because we do that in vaccine trials all the time. We say, 3 forms of birth control, you know, if you're a woman, or but it's just meant like you can't, you know, if you do, you have to. Yeah, but that's a good point, because volunteers do what they want to anyway, in my personal experience.
Would recruiting gay men work then? Because even if they have sex with another man.
There you go, maybe. What I was getting at though is beyond, right? No, I know, that's a good point. But the issue is that the Guillain-Barré was described associated with Zika, right? And we don't know that this is associated with necessarily inoculum or otherwise the severity of disease. And so we just don't know, right? And so we could give healthy people men, and it's not just pregnant women who have problems with Zika, you know. And so that idea I think is not totally dead in the water, but that's the major issue that they're grappling with. Zika is one of those things that explodes in an area and then it's gone. So by the time you get a trial up and running, what are you going to do? Like there's no incidence anymore. So how are you going to measure your efficacy? It's a big challenge. It's a big challenge. So anyway, I just wanted to point out that, you know, there were a bunch of vaccine efficacy trials for HIV that were total busts. And in fact, there was a bunch that were halted early for futility. Yeah, 2 of them. And then HIV infections were not, I mean, you can see that they were actually higher in the vaccines, right? So that was bad, right? I mean, there was one study, people have called a step trial, people had said it was a step back, it was a big Merck vaccine. And there was a suggestion of possible harm. So that almost killed the HIV vaccine. But while that was going on, the military was playing along on a prime boost regimen that was an RV-144. It was a 16,000 person trial in Thailand, and people thought it was not going to work. I mean, there was this letter that was signed by 20 luminaries, published in Science, saying, NIH, you are idiots for giving the military this much money to do this study. You need to pull the funding, it's futile, you know. But it worked. 33% turned the whole field on its head. And at the AIDS vaccine meeting that I went to over a year ago now, like 1/3 of all of the presentations were mentioned or derivative from this trial. Okay, I mean, it has completely revolutionized the field because it proved that a blended vaccine is possible. The published efficacy rate was at 33% at that 3.5 years. That 1 year was 60%. Can you imagine, you know, in a disease that kills over 25,000 people a week? So how many people died in Ebola? 12,000. About 12,000. And it's probably an underestimate. Okay. 12,000 in all of them, which is awful. It was an awful tragedy. But in the world of HIV, that is just another Wednesday. Wednesday after Wednesday, year after year, you know, I mean, and with all these emerging infectious diseases, that has become almost like a heartbeat attack that we don't hear anymore, right? I mean, and at any rate, hopefully, we all can all put our stethoscopes on some of these major trials coming out for HIV will actually make a difference because the amount of death and loss is almost a word to it anymore about HIV. But anyway, that's just me and my soapbox. But at any rate, what would be the difference if that, you know, a year you have that protection? And so what we've done is a lot of follow-on studies, first in the lab, which we partnered with this huge group of international collaborators to say, well, what works? And it turns out that there was a response to the B2 that was protective. And now we can look for that in other vaccine candidates. And also we put together other studies that have looked at boosts to see if you can keep that 60% going longer. And some of that's just coming out now. And it inspired this new collaboration to build on 144 with Gates, industry, NIH, all of that. And then us. But we're the ones that don't have all the money. And they are retooling that product, and it's now in this massive efficacy vaccine in Southern Africa. But it's focused on subtype C. And we're continuing to work on vaccines that work across the whole spectrum. And so with these mosaic inserts that protect against all the subtypes all around the world. So there are, and this is going into efficacy trials starting year in RSA. So two huge efforts going forward in HIV vaccines. I think in the next few years we'll see some major headlines. So that's the part on HIV. Maybe I'll just kind of pause here and we'll talk a little bit more about emerging infections. I touched on some of this already, but questions from Mr. Barr? Yes.
Right. Regarding to ethics on a placebo study, on a placebo volunteer, what do you think related with the IRB and also related with the volunteer, and then how much you pay for the volunteer?
Oh, so you were asking for volunteers when they come in, are they paid?
Yeah, and for the placebo study, placebo group.
Oh, for the placebo group, okay. Well, so this is the thing, is that when people come in to the study and they enroll, you can't tell them if they're getting the vaccine or the placebo. You're blind, they have to be blinded, and then you have to be blinded, because if you are, when you're judging the safety of what's going on with the vaccine, a lot of it is based on what the volunteers tell you. I have a headache, I feel itchy. You look at them and you can't measure headache, itchiness, whatever. They just need to tell you, and they are going to be less, if they know they got the active product, you can imagine that people might be a little bit more attuned to thinking they're going to have side effects, versus not. Or if they know they just got the placebo, it may not be as heightened in their mind. The same thing as me as an investigator. If I knew if people got a vaccine or if they got a placebo, and they had a headache and they're in the placebo group, I would just blow that up, and kind of unconsciously downgrade it to level 1 or level 2 or something like that. So yeah, you have to really be, so you can't tell people, so you have to pay them regardless. But we do pay our volunteers, their time is valuable, and people miss work, they do other things, and really they are the VIPs of medical research around the world that volunteers are on. And so, visits, they can be anywhere from $25 to, we have some visits where they are 2 weeks after a vaccine, and we'll have a subset of people that we actually hook up to a dialysis or a platelet donation vaccine, and we do apheresis, where we just pull out large numbers of their cells, but return most of their blood back. So we just selectively pull out cells. Like when you donate platelets and you selectively pull out platelets for donation, we selectively pull out the white cells so that we can study not just locally white cells, but all the different subsets, the different types of white cells. You have enough that you can actually see what they're doing in response to the vaccine. Anyway, so that's apheresis. Those apheresis visits, they might pay $400, right? It's 4 hours, they have to sit with their blood going out with their machine, so, but it's still, it's worth it. They deserve that for the time they give up and such, But it's really important, we always have to be trying to protect people. And you have to know that there are some people who volunteer for studies because they need the money, and they might not tell you the truth about their medical history. And that happens. I have to tell stories that you would never get the rest of the lecture. Yeah, very good question. So emerging infections. Obviously, we've seen this drumbeat of new outbreaks. It was avian influenza, SARS, MERS, Ebola, Zika. You can imagine this isn't going to stop. We're going to continue to have emerging infectious diseases. A lot of them are zoonotic. And with the globalization of travel and trade, this is going to only get more prominent. Okay, so SARS, MERS. Okay, and I'm not going to spend too much time on MERS, just except to note that your Army is doing the first MERS vaccine study right now. They're all done with vaccination, positive preliminary results. It's a DNA vaccine. DNA vaccine is not so immunogenic. Not so bad to prime, like to give as the first vaccine and then you come along with another boost with the viral vector. By itself, not so good, just generally. This may not end up being the answer, but it is, a first in medical history that's happening just down the street, and mostly done. And it's important because there are, outbreaks in the area of the world where we send people to, right? And when people get sick, they get really sick. They're very high mortality rates, right? So that's one of the reasons military investigators have been working on that and began in April, the first phase 1 study. we'll talk a little bit more about Ebola. I personally have been involved in running several vaccine studies for Ebola. And everyone knows that this highlighted gaps in the global public health response. And the fact that we just didn't have countermeasures, like diagnostics came up to speed quickly, but therapeutics, the military had spent, millions and millions of dollars of money developing therapeutics. But because of how difficult it is to stand up studies in the middle of an epidemic if you aren't ready for it, they weren't able to really test any of them. I mean, there was the ZMAP study, which was underpowered, and kind of weak results. But I mean, same thing with vaccines. I mean, that was largely over before we could get studies off the ground. And that is, I think, a real take-home message to the research community that you have to lean forward in the foxhole and be ready. And a number of us are working on some of these initiatives. Obviously, Ebola is a national security threat. It's a tremendous cost to human lives and livelihoods. I think not to be underestimated the distrust of governmental and international organizations that emerged on the ground in West Africa. Dr. Wilkinson's class is just over here. There you are. I was killed to see his lecture yesterday. And I got called by the commander, and I had it on my calendar, so Dr. Ford, I'm going to have to steal your slides. So I think, at least what I've heard, and you tell me what you think, that one of the biggest things that was good about the United States responding, even though there wasn't a lot of a medical response, it was more of a logistical response, was just sort of the reassurance, that the world was there, was supporting, they were behind the Liberian government, and it helped sort of restore trust. I don't know, Dr. Burke, is that fair?
Well, I think it was both. It both restored trust in the overall response, and also provided significant support as well. And I mentioned yesterday, the team that was sent, the medical team, they got involved in training health workers who were going to the ET, and the revelation from those health workers that were being trained suggested that the level of training provided for them improved their approach to the patients in ET when they returned them. Yes, at first they were like, not so organized, afraid. But as a result of the training, they were confident and they knew that there was something that was wrong and they changed those behavior and also helping increase the levels of our work. So it was both logistical support as well as both men, as you saw. Because I work with the training team, I was doing the training at Police Academy.
Oh, yes, so you went through that course that Colonel Nathan
Yes.
taught. Yeah, that's great. And so, so the U.S. military response included a training team that Dr. George was talking about, and it was led by a UCIS grad, by Colonel Patrick Hickey, who, so this is the military tropical medicine course. There is a tropical medicine certificate course that's 3 months long. He runs that course, but he led that team. So it's a small world, but he really has a lot of impactful memories from his time in Liberia. And one thing that he regrets is that he wasn't allowed to go into the ETUs and but he was happy to contribute as he could. A lot of us I was like this big and pregnant. So I stood up the vaccine trial in Nigeria. but a lot of people were jumping up and down. What we did is we helped logistically. And then we have to think about those things when we are developing the vaccine, right? Because if something like this helps out, what was probably the risk of the people that we sent to Liberia to help with the logistics for acquiring Ebola? Do you think they were high risk or low risk for Ebola? Yes, they were low risk. Yeah, and that's what someone said earlier. Yeah, that was probably going to be their bigger issue, and I think was well handled. But you have to think about it because the one vaccine, which we tested earlier, I'll talk about it a little bit, but actually went into efficacy studies and showed a positive signal. The numbers were very low in what was called the Ebola/Whooping ring vaccination study, which is run by the WHO and MSF in Guinea. And it was very promising, early efficacy signal for that vaccine product. Problem is, in phase 1 studies done in Lausanne, Switzerland, it gave people with Caucasian backgrounds, not a lot of them, but some, really bad reactive arthritis. Swollen joints, some amount of disability, right? If I'm walking into an ECU, shoot, I don't care, you know what I'm saying? It is worth it, right? Because I'm at high risk. But for the average shoulder that we might send, to help transport medical supplies, they're at low risk. Why would they give them that vaccine? Probably not, right? And so that's one of the reasons why we are involved in a multi-center phase 2 study that's vaccinating in the U.S. Well, those vaccinations are done, and then 6 different sites across Africa to move forward a vaccine platform that has a better side effect profile, but that is going to have to rely on the animal for efficacy studies. Because if we want a vaccine for our soldiers, we have to be at the right risk benefit. Does that make sense? Yeah. But honestly, any of the vaccine candidates that are, like in development right now in advance, I think they all work. And if I was going to go into an ETU and take care of patients, just give me any of them, right? But that risk is, that risk would be so much higher. Let's see. Obviously, it was global economic threat. And people might not know that Rare had been working in Ebola already. I mean, obviously, USAMRIID have, right? USAMRIID, they're the biothreat work of the Fort Detrick, and that's the Dustin Hoffman movie-based place. But it's an endemic pathogen as well. And so Rare investigators and collaborator in Uganda had actually published the first major survivor paper back in 2015 in Lancet ID and showed some of the long-term sequelae from the Uganda Bundibugyo outbreak, including chronic visual, hearing, joint, and memory problems. These are all things that we're starting to see in some of the huge survivor studies that are coming out of West Africa. Okay, and Rare had actually done the very first vaccine trial in Africa for Ebola in 2009. And this was in Uganda, and it was a DNA vaccine by itself, so not so immunogenic, right? But it was a start, and now what we've done is we've taken people who, back in 2009, were primed with the DNA, rolling them over and giving them the Vaccine Research Center at NIH, who is run by a prior military medical infectious disease researcher, by the way, John Mascola, and giving them their chimp adenovirus vaccine, which is one of the main candidates in advanced development with GSK. And then also checking if we can extend durability of protection with a boost with MVA, which is a modified vaccine, so it's a smallpox vaccine with bits of the surface glycoprotein target from Ebola in it. So at any rate, still building on what would have been started before the outbreak because we were moving forward. But obviously the outbreak totally revitalized the vaccine field. And this is just a pretty picture from our colleagues at the university. I stole the slide from Birmingham, and this shows the target, the surface glycoprotein that we're trying to immunize against for Ebola. And this is what the vaccine pipeline looks like for Ebola. There are 3 leading clinical candidates in advanced trials. We've had a role in developing all 3 of the Rare. And so some of these are being moved forward now outside of epidemic at different rates depending on, let's just say, the intrinsic motivation of the companies that are involved. So Johnson & Johnson, the vaccine group is called Johnson, they actually pull out their own money into this development effort and are pushing that product on through. And the status of Merck and GSK is a little bit less clear, but definitely the VSV vaccine has gone into stockpiles because they already have that efficacy signal that I discussed about. So I'm just going to talk a little bit about some of the studies that we did as examples. And so phase 1 studies, remember I was talking about their first in human, you look at the early safety, you figure out the dose. And so Rare took that VSV vaccine, the one that gave people in Switzerland some reactive arthritis. Now, our volunteers actually did fine, but we did the dose ranging and we down selected the dose that then went into that sausage study and got the positive study and ring vaccination. And Jason Magulius led that study. And our group kind of came in and put together assays that allowed the measurement of shedding of the VSV. And so this was just the final publication in the journal. And then this is the efficacy result, the success of human vaccination study. And so, while all of that was going on, in the U.S. with the VSP vaccine, we were continuing our work. I discussed some of the additional studies we were doing in Uganda, and then our site in Nigeria had just been doing observational research. But my boss went to a meeting in Switzerland at the WHO, and he came back, and he said to me, "Julie, we need a vaccine trial center in Nigeria." And I was like, "No," he said, "we need to do a phase 2 vaccine trial in Nigeria." And I remember saying, "Boss, we don't have a clinical trial center in Nigeria." He's like, "Make one." So we made one. We stood one up in less than 6 months. We started a phase 2 vaccine trial for the two ad3. Now, we were just one of many sites. A paper was just submitted to the Lancet 2 days ago, so we'll see how it goes. But it was our contribution, to be able to test in the relevant West African population that was not part of the epidemic. That's why we had to test it in Nigeria in the phase 2. Does that make sense? Sorry, just trying to pound home some of the reasons why we do things in different phases. Okay. And then, and now we're doing, of course, this large phase 2 for the Johnson & Johnson product, which is actually a prime boost adenovirus-based, then modified Yersinia Impro, which is the modified smallpox vaccine base, to give first in the U.S. and then overseas. And one of the interesting things that we're doing is we're actually purposely vaccinating HIV-infected volunteers. Because if we're, and this is something that, to my knowledge, was not done, at least in the initial phase 2 studies for the other products. And the reason for this is that if you're going to roll this out in Africa, you're not going to test people with HIV and not give it to them. Or they're coming out and going to test people for HIV before giving it to them. I guess that's the point, And so you just need to know if it's going to be safe in those populations and if it's going to work, or if it's not, like what you have to inform, how would you roll this out in a place where HIV is highly endemic, right? Because there are some vaccines, these are recombinant vaccines, like live vaccines, if you have a low CD4 count, you can make someone very, very sick by giving it to people. And that's one of the biggest reasons why we, as the military, actually got very involved in early HIV diagnostics. Because when you enter the military, what do you get? A whole bunch of vaccines. A lot of them are live viruses, right? And so we didn't want to be inadvertently giving people with this new, HTLV3 virus, these live vaccines, and making people really sick. And so that's why we got involved. But at any rate, important to know if you're going to roll something out globally, is it safe in HIV-infected people? And so far, what we're seeing is, yeah, it is. These are recombinant vaccines, you would expect that. But it's something that's unique, and because you have the Rare has had a whole set of vaccine trial sites now in Nigeria, but previously developed in Uganda, Kenya, Tanzania, and Mozambique. Sites all developed to test HIV vaccines. One vaccine trial is much like the next, really, in terms of the skill set required, if it's just safety and immunogenicity you're looking at. And so they were able to lend the keys to the HIV card to Ebola, and now get some very valuable data that's going to advance an important vaccine product towards licensure. And so this is kind of your military medical research enterprise being flexible to meet the needs of emerging infectious diseases. So Zika. Obviously, we see explosive spread of Zika. Some clinical manifestations. Only about 20% of infections are symptomatic, right? It's also characterized by non-purulent conjunctivitis, myalgia, arthralgia. Not so different to what? What's primarily on your differential diagnosis of Zika? Chick, very good. What else? Dengue, yeah. And then probably like malaria, you'd always check malaria, but it's not going to have a rash, right? But then there's the neurologic manifestations and congenital Zika syndrome, which is really the paramount clinical manifestation of all CVs. And obviously this was kind of illustrated nicely in this paper. And there are some lessons we can learn by what we did with vaccines to eliminate the congenital rubella syndrome. And now there's the, of course, congenital Zika syndrome that we're combating. This is just the paper that described the Guillain-Barré that was associated with the outbreak in French Polynesia. And so that's that's scary. People, there are people who still have not recovered after their right associated with this infection. Virology, I guess I would just point out, it is very similar. Okay, these are just the sequences. And the closer these are on these phylogenetic trees, the closer they are related genetically. Okay? So this is dengue. Dengue 1, 2, 3, 4, there's Zika. Some people say Zika should be dengue 5, right? It's very similar, okay? And so, but, we've just had a recently licensed vaccine against dengue, Sanofi Pasteur, just licensed vaccine against dengue. Now, is it a great vaccine? No, it kind of works in subtypes, some subtypes better than others, some age groups better than others, but, it's licensed in Mexico and Asia. And so there's been some success in flavivirus vaccines. So it gives us a lot of hope that this is going to be something that's doable for Zika. This is just showing some structure. Zika, though, is more complex than other flaviviruses because it has multiple tissue tropism. It goes, as we saw, brain, eye, placenta, testis, out the whole reproductive tract. It's shed quite a bit in body fluids, and it can be shed for a long time in body fluids after it's come in the blood. So it has a lot of that, and it's a good thing that's not identified, right? Because there are some very important Zika-specific considerations. Introduction of Zika to the West, this just shows how it kind of exploded out in the West, out of Brazil. And of course, we care about the U.S. because we're having cases, and it overlaps with our vector range, especially for Aedes albopictus, right, which goes all up our eastern seaboard. Okay, and it threatens our readiness. We've had 138 cases confirmed in military health system beneficiaries, and 3 in pregnant service members. 1 in a pregnant candidate. So our countermeasures are a DoD priority, and really our focus is on vaccine. We have good diagnostics. Vaccines are going to be a better answer than therapeutics in this case. And so the goals of immunization are to reduce the clinical burden of infection, generate herd immunity, interrupt virus transmission, whether it's through mosquitoes or sexual transmission or maternal transmission, and then have generally a public benefit of reduced suffering, reduced health care resource utilization, and then in places in the world where it's been such an explosive outbreak, it's affected the whole society and restore normalcy. And we can see that we were able to essentially with congenital rubella syndrome, we were essentially able to this all but disappeared because of the MMR vaccine. So prior flavivirus vaccines, so we made a lot of these, okay? Other flaviviruses besides dengue, JE, yellow fever is a very efficacious vaccine. JE vaccine developed where? Okay. And then the whole virion inactivated viruses for JE and TB are very effective. And so we now have numerous candidates in preclinical and clinical development for Zika and other candidates for other flavivirus vaccines. There's just a well-developed vaccine field for this class of viruses. There are some specific considerations. You have to figure out what strain are you going to use in your vaccine. You don't want to use some of the old strains. You want to do ones that are relevant to the current epidemic. Your early trials, right? First human safety, age de-escalation, that's important, right? You're not going to get into the babies first. You're going to start with the healthy young adults. And then you really want safety intersecting with the goal of preventing adverse neurologic and congenital outcomes. You want to make sure that whatever vaccine you're doing is safe for pregnancy or immunosuppressed, okay? So then you might be concerned about live attenuated vaccines in this case, right? And so the rare approach is actually it's a killed vaccine, okay? The purified and activated vaccine, or CPAC. okay? And then it says safety and immunogenicity in naive and primed populations, right? So if you get infected with dengue, and then you get infected again with another serotype, what happens? Yeah, you have a higher risk of dengue hemorrhagic fever, right? What if you get infected with dengue, and then you get vaccinated against Zika? I mean, we don't know, but that could be a problem, right? You know, so these are all tricks and specific considerations that, you know, that the field of developing vaccines have to think about these things. And so the study that we're doing at RARE is actually looking at, is giving people the JE vaccine or the yellow fever vaccine. So giving them the closest thing you can do to like a prior flavivirus infection, and then not pre-vaccinating people, and then checking the safety of the rare product in people who've been flavivirus prime. So that's I think a very important clinical trial design characteristic of the work that we're doing here. So the product that's the farthest along is the DNA product developed by the Vaccine Research Center at NIH. And we're also collaborating with them very closely for the development of the Zika vaccine, okay, which is the Zika purified and activated vaccine. Okay, so I'll just go through two or three more slides and give folks a little bit of a break. What I just wanted to know is that, as bureaucratic as military research can be, this was a response that really happened on a dime. In November of 2015, we saw the first case of Zika in the US. By February, we started producing our vaccine product in our bioproduction facility. Okay, by June, it was 100% protection in mice, and we were just able to reach out to an HIV collaborator who had some Brazilian postdocs who were raring to go on this and do these mice studies at Harvard. And then we licensed to Sanofi, right? Because who can push this through to ultimate licensure? Maybe the study that just licensed a flaky vaccine in a bunch of countries that are endemic to Zika and already have a clinical trial network set up. And so I think they were probably the best industrial partner that, to fit with that. And of course, they were our industrial partner for RE144. So we just call it the same people, right? And so being able to leverage our history in vaccine development helped us move forward towards tech transfer. Because ultimately, the Army's not going to make huge batches of this. We proved that the Zika vaccine provided 100% protection in rhesus monkeys, again with a collaboration over at Harvard. And then by November, okay, so November to November, in the arm of a volunteer, okay, at the Rare Clinical Trials Center down the street. And there are a whole bunch of different clinical trials of this going on right now, to include some of our colleagues across the street at NIH, but also up at Harvard in Puerto Rico, and looking at people who have a natural prime to flavivirus, but as opposed to kind of an artificial one with vaccines like we're doing, and then at St. Louis. So I think I'll stop there and ask if people have any questions. Thanks so much for your attention, and I hope that I've given you a little bit of a peek